Hey there, Algebra 1 class. It seems like many of you are, well, for the 9 of you, kind of all are on a little bit of your own program. So I hope these lectures are actually helpful because some of you are playing catch up or some of you are ready to move on to the next thing. I hope this is a good way for you to be able to go back and see what's going on. In today's lecture, we're going to talk about how to factor polynomials with the greatest common factor. And I want to introduce to you, this is Silas. He's my 3.5-year-old. Hi. And there's Kai. He's my 5-year-old. And they're sitting over here having snack while I record this lecture after. All right, so without further ado, let me move on to the main event. Let me tilt this down a little bit. Maybe that'll get better. A little more. That's better. All right. Factoring polynomials by using the greatest common factor. So the deal is here is when you factor, essentially what you're doing is undistributing. So you can read the slides here. But basically what we're saying is there something that I can pull out of a polynomial or something that I can divide out of a polynomial. When you have something, a polynomial in factored form, it's the product of two other polynomials being multiplied together. The reason this is so important is when you move on to Algebra 2, when we have to solve equations and functions for certain values, this is how you're going to do it. Factoring is a really important way to see the zeros of a function or the places where a certain input gives you a specific output that you're looking for. So what in the world does this mean? All right, let's start with the basics, and again, we're going to get more difficult as we progress through this lecture. So the first one says, factor each polynomial, check your answer, and I made a great discovery. I can change the color of my screen shade. Look at that, isn't that cool? Oh, when I accidentally clicked on it, I was mesmerized. All right, factor each polynomial, check your answer. What they want you to do here is, what does 2x squared and 4 have in common? Well, they both have a 2 in common, right? And this is what it's going on to say is, oh, well, the greatest common factor of both of these terms is a 2, which means that I can remove a 2 from both terms. So what I'm going to do is I'm going to take a 2 out of 2x squared, and I'm going to take a 2 out of negative 4. And essentially what I've just done is I've undistributed. Basically, I've divided each of these by 2 to get what's found inside the parentheses. And then what I want to do here is I want to actually check my work. So like, okay, did what I factor out make sense? Can I distribute it back to get the original problem? Right? 2 times x squared is 2x squared, and 2 times negative 2 is indeed 4. Therefore, my answer checks out. Aligning common factors can help you determine your greatest common factor of 2 or more. Let me just give you a couple more examples here. So in this polynomial, what do I have in common between 8x to the third, 4x squared, and 16x? Well, just right off the bat, 4, right, and x. So really what I'm saying is I can take a 4x out of each one of these, and the way I think of it is I can divide each one of... Silas needs to go to the bathroom, so I'm going to pause the video and come right back. All right, we're back now. And so on this next polynomial, again, I've got a 4x in common. So what I'm really doing is I can divide each one of these terms by 4x, right? And I'm taking 8x cubed divided by 4x, and I get 2x squared minus x minus 4. Right? And that's the big idea of factoring. And when I show you what they do in the book here, you can say, wait a minute, all right, what's your greatest common factor? Of course my greatest common factor is 4x. And I take a 4x out of each one of these terms, because if I multiply these together, I get the original polynomial. And I can then check my answer at the end. If I distribute this 4x to each one of these terms, I get the original answer. What do you guys think of that? Does that look pretty good? Looks good. Yeah, there you go. All right. Let me just show you a couple more examples, and then I'll release you on your own thing. Hey, on this one, when you have two negatives, or the leading term is negative, the best thing to do is rewrite it is negative 12x squared minus 14x. And of course, Notice how they're both negative? So I can take out a -1 right off the bat. Let's do that right off the bat. Let's just make this -1 out front. And now I've got 12x squared plus 14x. And now what's the greatest common factor inside? Well, you're probably saying to yourself, 2x. And that's right. So really what I'm going to do is I'm going to take a 2x out of both of these, and I'm going to carry that -1 all the way down like that. So you see again, here's my -1. They have a 2 in common. They have an x in common. So I'm going to factor out a 2x from each one of the terms. And then I have to remember to apply this -1 to the 2x out in front. So -1 times 2x is -2x. And this is my factored form. So do me a favor, check your answer. If you multiply -2x by 7 plus 6x, do you get the original polynomial? And that's what this little caution is. When you factor out a -1 as the first step, be sure to include it in all the other steps as well. All right, now this is when I was discovering the great pink example here that I can change the screen shade. And when I look at this polynomial, 3x cubed plus 2x squared minus 10, when you look at that and you say, you know what, I don't see anything in common, you're absolutely right. This polynomial is already factored all the way. There's nothing you can do about it. So keep in mind, not every polynomial is factorable. Not every chemistry equation has common factors. So just keep that in mind. Go ahead and try these 6 problems. Try to factor out what you can, and then continue on to the next part of the lecture. Hey, in this next set of problems, you're going to write expressions that involve length and width of a rectangle as area. And again, area is length times width. So if I give you the area written as a polynomial, you should be able to factor out those pieces that make it up. So when you get a problem like this, it says the area of a court for a game of squash is 9x squared plus 6x. Square meters, factor out the possible expressions for the dimension of the court. Well, what do 9x squared and 6x have in common? Minus k. They both have a 3x in common. So literally what I'm doing here is I'm factoring out a 3x of both terms, right? And I undistribute it, and then I know like one of these components is the length, and one of these components is the width. You should be able to try these problems now. They're not very challenging word problems. They tie right together with what we're doing. And then when you're done, go ahead and pause the video, and then come back to the next set of problems. What am I doing? I'm recording a lecture for my class, my algebra students. I am in the middle of talking, so you guys just have to wait till I'm done. You want paper. Pause the video. Okay, we're back again. Just remember, this is what it's like to have small children. Constant interruptions. You can write down a number right now. How many more times do you think this video will get interrupted before the end of it? Okay, moving on. Sometimes the greatest common factor is actually a binomial. Sometimes it can even be a polynomial, something that it has in common. In that case, you can actually factor out the entire binomial. You can undistribute an entire binomial, and this is the background for what's called factoring by grouping. So check out this example. In this example, it says factor each expression. Well, in this one, both expressions have an x plus 2 in common. So I can literally factor that out of both. I can undistribute it. And what it looks like is I pull it out of each one of these. Isn't that amazing, right? They both have an x plus 2, so therefore I move it out. Because if I was going to distribute it, I would multiply 5 by x plus 2, and I would multiply 3x by x plus 2, right? And then you can check your work to see where it ends up. In this one here, both, that's really weird looking. They both have a b squared plus 1 in parentheses. Well, I can factor that out of both parts. Now, when you don't see anything here, it's really being multiplied by 1, right? So in this case, I'm saying, hey, there's actually an implied 1 out in front. So I divide each part of this polynomial by b squared plus 1, and I end up factoring, undistributing it, and bringing it out front. Isn't that wild? Take that in for a second. So the next part of your worksheet, they want you to practice this because you need to be able to do this in order to do the final part, which is factoring by grouping. So again, you're going to factor this expression, and then on problem 10, you're going to do that one. All right, the last thing we need to do is what's called grouping. And again, finding common factors, and this is a two-step process. So what you're going to do is you're going to find a common factor in both, and then you're going to do pull out a binomial factor from each term. It's really a really cool thing. So in this one, it says factor each polynomial by grouping, and then check your answer. So in this first part of the polynomial, you can see there's a 2h to the third in common. So first of all, I'm going to group my terms, right? The second thing I'm going to do is I'm going to find a common factor. So the first one here, there's a 2h to the third in 6h to the fourth and 4h to the third, right? So basically, I factored that out. On this one over here, I've got 12h minus 8. They both have a 4 in common. Okay, so I factor out a 4. I get 3h minus 2 as its remaining portion. Now you see both pieces have a 3h minus 2 in them. So I'm now going to factor those out. I'm going to pull those out of both expressions. And there I have now completely factored. Actually, I can take a 2 out of there as well. But I have now completely factored this. Now, to check your work, you're simply going to multiply these two binomials together, and you'll end up right where you started. Very cool. Okay, that's the big idea. Let me do one of these problems for you just to help you see exactly how it works. I want you to try the remaining 5. When you're done, continue the video and check your solutions, and then I'll give you an additional assignment to try. So, number 11. First of all, I'm going to group these together like this. And now I'm going to say, all right, what does this first one have in common? Well, it has a 2x squared in common. So 2x squared, which means I'm left with x plus 4. Plus, what do these both have in common? Oh, it's a 3. 3. And that means I'm left with x plus 4. Oh, well now they both have an x plus 4 in common. So I write x plus 4. And then the remaining pieces are 2x squared plus 3. I love these problems. Once you get the, not even necessarily the hang of it, but you understand how it's supposed to play out, they're actually really a lot of fun. All right, pause the video here. It's been long enough, 13 minutes. Go ahead and finish these problems, and when you're done, I want you to check your answers and bring your questions to class. Your assignment is 7.2, these problems. There's 22 problems. You're going to work on these during our next class period, which is the plan is Monday. And that's it. You guys have a great week. Here's your solutions.